Sample problem 3B on page 93. Find the component velocities of a helicopter traveling 95 kilometers per hour at an angle of 35 degrees to the ground. So what they mean by that is 35 above the horizon. We are given our resultant vector, 95 kilometers per hour is our, and this is, I'm going to use V sub r. We sometimes use that to mean resultant vector. In this case, of course, we're dealing with a velocity.
Please excuse the interruption. There's a white Suzuki Forenzo with its lights on in the parking lot. License plate number EVH5496. Thank you.
So this is standing for resultant velocity, or total velocity. We'll sometimes mark that. Actually, why don't we just make that V? So this is the velocity of the helicopter. Because that velocity is at an angle, there is a component of the velocity that's on the x-axis and a component that's on the y. So here I'm going to introduce these two things, which are going to be with you until January. This is velocity sub x. This is velocity sub y. Okay? And we can have displacement on the x and y, we can have velocity on the x and y, we can have acceleration on the x and y. Anything that is a vector and can be and has a direction as well as a magnitude can typically be broken up into its components. Okay, so what we're given is this angle and this resultant. We're going to use trig. Opposite and hypotenuse are connected by what trig function? Sine. So the sine of theta is the opposite over the hypotenuse. In this case, our opposite is our y velocity, and our hypotenuse is our velocity. It's our total velocity. Okay. Well, we want to solve right now for our y velocity. So the sine of theta times our total velocity will give us our v sub y. Simple, clear. So go ahead and do sine. So what we would take is sine of 35 degrees times 95 kilometers per hour will give us our v sub y. Sine 35 times 95, and we get a v sub y of 54.48976.145. What are our units? Kilometers per hour. They haven't changed. We multiplied a vector by a scalar. The angle is a scalar. We maintain the vector and we maintain the units. So kilometers per hour. And how many sig figs can we have? 2. So this is going to just be, in our final answer, 54 kilometers per hour is v sub y. And I typically go back and add these because it's helpful to me. Okay, so now we want to find our v sub x. I'm going to erase this. And I'm going to work in a different color just to differentiate it. So, what trig function connects adjacent and a hypotenuse? Cosine. So the cosine of theta is equal to the adjacent over the hypotenuse. In this case, that's our v sub x over our velocity. So cosine of theta times velocity, because we want to solve for v sub x, is going to give us our v sub x. So now we can write it all in. Cosine of 35 degrees times 95 km per hour gives us v sub x. Cosine 35 times 95 gives us 77.8194441 km per hour is our v sub x. How many sig figs can we have? Still 2. So this is 78 km per hour is equal to Vx. Okay? We don't have to find the angle, it was given for us. So we're just finding the components of the velocity.